So we've just done now a whole section on differentiation. Fabulous, in the bag, done. Now, if I had a function, so let's get a different colour pen, shall we, and try not to drop it. We have y equals 3x to the 4 minus 5x plus 2, a function like that. We could then differentiate that, so dy by dx. We bring the power down, take one from the power, nice and easy. 12x cubed minus 5, should be able to know how to do that. So in general, we had, if y equals ax to the n, and its derivative, dy by dx, the a will multiply with the n, multiply by x, n to the minus 1. That's simple. You don't need to do anything else with that. However, if I had a derivative on its own of ax to the power of n, like that, and I wanted to get back to y, I'd have to reverse this process. How would I reverse the process to get back from dy by dx to y? Well, this is the process of integration. Integration is the reverse of differentiation for the time being, until we move on a little bit in this section. So how would we get back from the 12x cubed back to the 3x to the 4? Well, we can see clearly this 3 would have to increase by 1 to get back to 4. But we don't want 12x to the 4, do we? So we'd have ax to the n plus 1. Fabulous. We'd have 12x to the 4. Well, that's not what we want. We want 3x to the 4. How do we get back from the 12 to the 3? Well, you could see I'd have to divide by this new power in order to get back to the 3 that I want. So I'd have ax to the n plus 1 divided by n plus 1. So I add 1 to the power and divide by that new power that I gain. That is the process of integration, getting back to what you'd have. Now, as far as you know, you've been solving these equations ever since, right? So when you differentiate down, you get to a differential equation, of which there's a whole video on that I've already put out already. Don't need to go into much depth in that. But the idea of reversing this process to get back to what you want is the process of reversing differentiation. Because differentiation is a process of finding the gradient function. So if I take that y equals ax to the n again, like that, and I multiply by the n and then divide that by the n, and did that, I'd see that I get back to ax to the n because my n's will cancel out. So you can see where this process actually comes from. Teachers I never have seen do it this way. And obviously there's a teacher, I'd want to have a new power done. No, it's not. Integration is a process of summation, but I understand that, but also it's a process of actually where does it all come from. Because you might think, oh, this has just been plucked out of thin air. Or which, yeah, it might well have been plucked out of thin air. But that's the thing. You're meant to have it plucked out of thin air. But then, it's like, well, where's that 2 gone? It's like, where? That 2's gone when I differentiated. But yeah, I know that it should go. But why? Where's it gone now? It's like, how do I get back from there to there? It's like, where? It's like, where? Where's that come from? Well, because we need this plus c. This plus c is what's called the constant of integration. Because you lose it via the process of differentiation, so in order to get it back, you have to have some constant at the end, which you would find by getting some more information in the question. For example. So, if I take my differential equation dy by dx equals 12x cubed minus, I'll write it as 5x to the naught, you'll see why in a moment. Get a different colour pen. I'm going to try and get back to this y that we had. So what is my y then? My y, well, using this process I've just said, I'd have 12x to the 4 over 4 minus, well, this is going to be a bit stupid because I've got 5x to the 0. It's like, what? What's going on there, right? So you're going to end up, well, you get minus 5 x to the 1 over 1. So you just get minus 5x. And obviously I got my plus c at the end from the constant of integration that you're going to end up finding. So I can simplify this to 3x to the 4 minus 5x plus c. And that c you could find with some extra information that you might have in a question, which we're going to look at later on, finding this constant c. So we'd use this symbol of a summation. If we integrated, and take my integrand, this curly thing, they do, just as a warning, if you do not do this correctly and it looks a bit skewy, it looks a bit like that, you get no marks. You have to make sure you can do your curl correctly. If you don't, yeah, no marks. It's silly. If I wanted to integrate ax to the n in respect to x, so these bits are vital. If you do those correctly, then you can use the process of integration and find out this new rule of the ax to the n plus 1 over n plus 1 plus c. And that is how we integrate a standard polynomial of ax to the power of n. In the next video, we might go through some examples of these and then some classic ways where we can find what that y is equal to.